Okay, moving on to the other examples. This next example is also an example of an annuity. In this one, we're wanting to save $4,800 a year for 8 years, and we need to solve for how much we'll have at the end of that 8-year period if we're going to earn 4%. So again, we don't need, the present value is not applicable because we're dealing with a payment and we want to know how much it will be in the future. Interest rate is 4%, 8 periods. We can go to the tables. Again, we'll be using table 3, which is future value of an annuity. And the factor for 4% in 8 periods is 9.214. If we multiply that by the payment, that gives us $44,227, which is how much we will have accumulated at the end of the 8-year period. And again, we can do this using Excel. In determining what formula to use for Excel, look at what you're solving for. In this case, yes, we have a payment, but we're solving for the future value. So that is going to be the formula we'll use. Now, you notice that we're filling in the rate of 4%, the periods of 8, and then we're filling in the payment. Present value remains vacant or empty because there is no present value. And then if we hit enter, we again come up with a dollar amount very similar to what we did with using the tables. In number 5, again, we're dealing with a payment, but this time we're going to be solving for the payment. We have been paid a lump sum of $400,000 when we're 65. We're going to invest it at 6%, and we need to know how much we'll be able to withdraw if we want to withdraw it equally over 7 years. So future value is not an issue. That's not what we're dealing with. We're dealing with the present value, which is what we've been given, and we need to solve for the payment. Now, we're going to go to table 4, which in the book, if we use a table, which is the present value of an annuity. Previously, we were using the future value of an annuity. So we'll go to that same table. That table operates in the same fashion. We'll find the intersection of 6% and 7 periods, and the factor is 5.582. In this case, because we're solving for the payment, we will take the present value, divide it by that factor, and what we will be able to do is withdraw $71,659 every year for 7 years. And again, we can do the same thing with Excel using the payment function, dropping in the rate, the number of periods, and the present value, and it gives us something very close. The next example, we're actually going to solve for present value. I have payment here, but that's not the case. We have a situation in which we need $48,000 at the end of every year to live off for 6 years after we retire. So we need to know how much we need to invest today in order to do that. So we're solving for the present value. The interest rate is 4%. We have 6 periods. We need the $48,000, so that's our payment. We will again go to table 4, which is the present value of an annuity. The factor at the intersection of 4% and 6 periods is 5.242. And we multiply that by our payment, and that gives us a present value of $251,616. Then again, we're solving for the present value, so we will use the present value formula, fill in the rate, the number of periods, and the payment. In this case, we have no future value. and we get something very close. Now, this last example is a little bit different. What this last example does is it looks at using time value of money to evaluate alternatives. So we have two plans that in this scenario, we're going to make an initial investment of $18,000. We have two options, Plan A and Plan B. Plan A gives us 5-year cash flows as indicated. Plan B gives us a little bit of a different cash flow. The investment is the same. Our required rate of return is 6%. We need to figure out which is the better investment to make. So what we're going to do is present value each of these cash flows. Notice I can't use payment because the payments are not of equal dollar amount. So an annuity will not work. So in Plan A, what I did was I took the $18,000, that's a negative outflow, and that's being made today. So present value is not applicable. The $18,000 is the present value. Then I took each of the annual cash flows, and what I did was I found the factor out of table 2. This is present value of a lump sum. I found the factor for 6% and 1 year, 2 year, 3 year, 4 year, 5 year. And then I just multiplied the cash flow for that year times the factor. And at the end of 5 years, the present value, net present value of the cash flows for Plan A is $2,183. Then I did exactly the same thing for Plan B, same period of time. So the factors are exactly the same, but the payments, the cash flows vary. And so you come down and the total net present value is $3,040. So in this case, because the net present value for Plan B is in excess of Plan A, at least on the dollars alone, we would go with Plan A. And you can kind of see why it might, intuitively, why it might be the case. Time value of money means the money we get sooner rather than later has greater value. And if you look at Plan A, the early years, their cash flows are smaller than in Plan B and higher in the later years. Because let me put a total here real quickly. I didn't do that, but if you total the cash inflows for each of the plans, it's the same cash inflow over the 5-year period. The only thing that's changing from one plan to the next is the timing of the cash flows. And dollars received today have greater value than dollars received in the future.